I'm back. Let's talk about the graphs of cosecant and secant, and let's see where that takes us. So we're going to do the same exact thing we were doing with cotangent and tangent. We are just going to pick points and see what happens. All right, so here it goes. Let's pick. We're going to use those same points that we were using. I think 5 will be good again if we pick those. So let's do negative pi over 2 first. So if you guys remember, if we're doing cosecant, cosecant x. So cosecant negative pi over 2. Remember, cosecant's a reciprocal of what? Answer, sine. So we can rewrite this as 1 over sine of negative pi over 2. Okay, so what is the sine of negative pi over 2? Well, let's check it. So let's go to the unit circle. Again, negative pi over 2 is going to be down here, the same position as 3 pi over 2. Remember, negative angles, we open clockwise. So that's going to be negative pi over 2. And so if that's negative pi over 2, the y value of that is, well, I think it's negative 1, right? The y value of that point. So yeah, negative 1 is what we're going to fill in there. All right, so here we go. So negative pi over 2, sine of negative pi over 2 is negative 1. 1 divided by negative 1 is negative 1. There we go. So we know the y value here. Let's keep it going. How about this? Cosecant of negative pi over 4. Let's try to figure that out. Well, it's 1 over the sine of negative pi over 4, which is the same thing as, okay, let's find the sine of negative pi over 4. Well, negative pi over 4 is right here, remember? So negative pi over 4, the y value of that point, that's still the middle value, but notice the y value is still negative. So the middle value we have to choose from out of 1/2 square root of 2 over 2 and square root of 3 over 2 is the square root of 2 over 2. So that's going to be the answer. It's going to be negative square root of 2 over 2. So this is going to be 1 over negative square root of 2 over 2. Alright, so we got a little simplification to do here. Remember, division is the same thing as multiplying by the reciprocal. Okay? So instead of taking 1 divided by this whole thing right here, I could always take 1 times that flipped. Alright? So, and 1 times anything is itself, right? So it's going to be negative 2 over the square root of 2. And when we need to simplify this radical, so we need to multiply by the square root of 2 over the square root of 2. Keep going. So it's going to be negative 2 times the square root of 2 over 2. And what happens to the 2's? Well, they cancel. So this will be negative square root of 2. When I say cancel, guys, I mean they divide to equal 1. So negative square root of 2 would be the answer for that. Now, if you type that into your calculator, let me figure this out real quick. So negative square root of 2. Square root of 2 is 1.41. So negative 1.41 would be the decimal approximation. All right, moving on. Let's go 0. All right, here we go. So let's find the cosecant of 0. Well, that's the same thing as 1 over sine of 0. All right, so you guys tell me, what is the sine of 0? Answer? Yep, 0. This will be 0. 1 over 0, my bad. And so, what's 1 divided by 0? Answer is undefined. Okay, now let me just kind of speed this up again like I did last time. Pi over 4. If I take the cosecant of pi over 4, it's going to give me the same thing except opposite sign here. So this is going to be positive square root of 2, which is positive 1.41. And pi over 2. It's going to be the same thing as negative pi over 2, except the sign is going to be different, so it's going to be positive 1. Okay. All right, the reason for that, you can look back in the unit circle to figure that out. Okay, but anyways, let me graph all these. I haven't graphed any of these at all. So here goes. We said negative pi over 2, the y value is negative 1. So negative pi over 2 is about right there. The y value, excuse me, negative 1. That'd be that point. That's negative pi over 4, which would be about right here. The y value is, it's smaller. It's negative 1.41. So let's approximate negative 1.41 to be about right there. A little bit lower than negative 1. Okay. And 0 is undefined. So remember, what undefined looks like is an asymptote. Okay. Let's keep going. What else? Pi over 4. The answer is square root of 2. So that's going to be it's going to be positive square root of 2. So let's say this is pi over 4 right here. Let's say this is pi over 2. Okay, so pi over 4 would be halfway between 0 and pi over 2. So therefore this point would be about right there. Pi over 2 we've already found is 1. Okay, and plot this right here. Alright. Now I know it probably isn't a good enough picture for you guys to understand. So let me just keep this going a little bit further. So what if I went on to 3 pi over 4? Guys, you can check this, you can pause this and do this. The sign of 3 pi over 4, the answer is going to be positive square root of 2 again, which is 1.41. Okay. And then let's just do one more for good measure. So let's go on to pi. If I take the cosecant of pi, cosecant of pi is going to be, it's 1 divided by 0, which is undefined. All right, there we go. So that's going to be an asymptote. And at 3 pi over 4, which would be about right there, that's going to be the same value as at pi over 2, or yeah, pi over 4. Okay. So guys, what these graphs are going to look like, they're going to look like U's. But they're supposed to behave asymptotically. Okay. And this guy right here, negative pi is going to be an asymptote. There we go. So guys, this is going to keep repeating up and down, up and down. So the next one, this one was opening down, this one's opening up. The next one right here is going to start at negative 1 and it's going to open down. So at 2 pi, that's going to be an asymptote. And the next one is going to open up. So it's going to keep repeating that cycle. Okay. So, a couple things to write about cosecant. Cosecant. It has no zeros. Okay? Y equals cosecant x has vertical asymptotes. At x equals, not x equals, let's just do multiples of pi. Alright? That's vertical asymptotes at multiples of pi. And then the last thing I want to mention with cosecant, the period is going to be, now think about this. How long does it take to make a complete cycle? So guys, how long does it take to repeat itself? So right here, I've got a U opening up. It does not repeat itself right here. This is a U opening down. Well, how long does it take for you to get back to a U opening up? So right here, the first asymptote right here is at 0. This asymptote gives us a U opening down on the next piece of graph. And so right here, it repeats itself again. So if we go from 0 to 2 pi for it to repeat itself, the period is going to be 2 pi, just like with sine and cosine. Okay, so the period is 2 pi. And actually, let me impose, I don't know if that's the right word, let me go ahead and graph the sine function and show you some relationships here. So if I were to graph the sine function, at the same time I'm going to graph it in red. Remember, the sine function starts at 0, 0, and it has a maximum at pi over 2, and it gets back to 0 at pi, and it has a minimum at 3 pi over 2, and then it gets back to 0 at 2 pi. So if I were to graph the sine function, it would look like this. See the relationship there? And I can keep going. So every maximum or minimum, so for example, pi over 2 is a maximum for sine, it's going to be a minimum for cosecant, and vice versa. So this is a minimum for sine right here, that's going to be a maximum for cosecant. Alright, so they're going to meet every single time like that. So that's the relationship between the two graphs. Alright, I know I've bored you guys already with this. This is not the most fun thing to teach, but I'm going to try to show you this last one. And I tell you what, you would do the last one the same way, so why don't I just speed this up a little bit. Let me just graph it and talk about it after I get it graphed. So let's do secant next. You would do it exactly the same way. You can pick any points that you want. You can pick those 5. To be honest, looking back, I'm not sure those 5 are the best points to pick, but too late. We're going with it. So let me just first talk about this. Well, actually, let me go about it a different way. Let's mention this here. If we're trying to graph secant, that's the same thing as 1 over cosine of x. So we're going to get asymptotes when cosine x is equal to 0. Alright, if that bottom number is 0, then we can't divide by 0, so therefore it's going to give us an asymptote. So guys, what I want you to think about your unit circle. At what places are my cosine values equal to 0? Well, my cosine value here, my x value of that point is 1, right? So we're looking for where our x values are equal to 0. Our x values is equal to 0 at pi over 2 and at 3 pi over 2, so at odd multiples of pi over 2. Next one would be 5 pi over 2. You can also do negative pi over 2, things like that. So I'm going to try to plot those real quick. Sorry, wrong one. I'm going to try to plot these. So at pi over 2, at odd multiples of pi over 2, that is going to be an asymptote. Because we can't divide by 0. That's when that's going to be equal to 0. Alright? So pi over 2, next one would be 3 pi over 2. Okay, the next one would be, this one over here would be negative pi over 2. So all those are going to be asymptotes. And I'm just going to go and tell you guys, this is going to look similar to cosecant. Just the first u, though, is going to be in a different spot. And that's going to be right here. So we're going to have u here. The next one's going to be at pi, but it's going to be a u opening down. And then the next one's going to keep repeating that over and over. So it's going to keep alternating. Opening up, opening down. This guy would be opening down. Okay. Alright, so I'm skipping that step, and let me just write these facts. It's not going to let me extend the page. So, y equals secant. Again, no zeros. Y equals secant has vertical asymptotes. Be careful how you abbreviate asymptotes. Okay, so vertical asymptotes at odd multiples of pi over 2. And the period again, you could think, how long does it take to repeat? Well, it doesn't, well, you can look at it like this. So let's say we look at that point right there. How long does it take to get us the point, the value of 1 again? So it's going to take us 2 pi for that to happen as well. So the period's 2 pi. So it's going to take 2 pi for that to repeat. And you can find that a different way as well. Alright, so that is those are what the graphs look like. My next video will be about how to transform those graphs and how to graph other, well, what I mean by that is, if we have this secant, for example, the secant of 2x, or if we do some sort of transformations to those, if you know what they basically look like, if you know these facts about these 3 facts, then you can use that and you can graph pretty much anything that deals with secant. Alright? So that's all I've got. I'll stop right there. Thanks, guys. Have at it.